Hello, my name is Professor Ajman, and this is episode 14 of the Quadratic series, where we are going to look at solving quadratics using the quadratic formula. We're also going to look at where the quadratic formula comes from. We have three examples. They are on your screen now. So if your homework problems look like this, then this is the correct video for you. If you're confident that you can solve these problems using the quadratic formula, then I would recommend going on to the next episode in the quadratic series. For everyone else, let's go ahead and jump into it. So the first thing I want to do is look at where the quadratic formula comes from. And to do that, we're going to take a standard form quadratic, meaning we have this quadratic that is ax squared plus bx plus c. And we set it equal to 0, and we're going to derive the quadratic formula. If we think back to the last episode in this series where we learned how to complete the square, I said a couple times in that video that completing the square will work to solve any quadratic, even if it's not factorable. So this is a quadratic, so we should be able to complete the square on it to solve it and get what x is equal to. So let's go ahead and complete the square on this. The first step in completing the square, we should remember from last video, is to divide everything by the coefficient in front of x squared. In this case, that's a. So if we divide everything by a, we're going to have x squared plus b over ax plus c over a is equal to 0 divided by a, anything divided by, or 0 divided by anything is 0. Our next step is going to be moving the constant term, this c divided by a, over to the other side. So x squared plus b over ax equals negative c over a. Now we need to find our magic number, is what we called it in the last video, where we take our coefficient in front of the x, this b over a, and we divide it by 2. Now taking b over a, which is a fraction, and dividing it by 2, that's the same thing as multiplying by 1/2. So we're going to do this and then we're going to square it. So multiplying fractions, remember we multiply straight across the top, straight across the bottom. So we have b over 2a. And if we square this, we need to square each of these terms individually. So we get b squared over 2 squared is 4, a squared. This we need to add to both sides of the equation to keep it balanced and make the left side of our equation a perfect square trinomial. So x squared plus b over ax plus b squared over 4a squared is equal to b squared over 4a squared minus c over a. Now that we have this left side in a perfect square trinomial, we can factor it very easily. It will factor into x plus whatever our b divided by 2 term is. And when I say b, I mean the number in front of x. So in this example, it's b over a. So when we divided it by 2, we got b over 2a. So this is going to factor into x plus b over 2a squared. And that's a little trick that we learned in the last video. On the right side, we need to combine these into one fraction. If we're going to combine fractions, adding or subtracting, they need to have a common denominator. So 4a squared and a. To make these have a common denominator, I'm going to multiply this c over a by 4a cubed. Sorry, 4a. if we do that, we'll do some more side work. If we do that, we have b squared over 4a squared minus 4ac over 4a squared. So now I can combine the tops and write it over one denominator. So I have b squared minus 4ac all over 4a squared. Now we're trying to isolate x, so we need to get rid of the squared. We get rid of it by taking the square root of both sides, leaving us with just an x plus b over 2a on the left. And on the right, we have on top, we're just going to leave this as a square root of b squared minus 4ac. But on the bottom, we can actually take the square root of each of these terms because they're both perfect squares. The square root of 4 is 2, and the square root of a squared is a. And we know that when we take the square root, we're going to get this plus or minus. So now the last thing that I have to do to get x is just move this b over 2a over to the right side. So x is equal to negative b over 2a plus or minus square root b squared minus 4ac over 2a. These are both fractions and they share a common denominator already, so if I want to, I can rewrite this as x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. Meaning if I'm given any quadratic, as long as I can identify what a, b, and c are, I can plug them into this equation and get what x is equal to without factoring, without completing the square, without any of that. So let's try it. Let's apply it to a few different examples and see what happens. I have x squared plus 6x minus 3. We need to identify what a is, what b is, and what c is. So a is 1, b is positive 6, and c is negative 3. Using our quadratic formula of x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Alright, I try to color code it to make it a little bit easier to see where these numbers are going to go in, but we can go ahead and just substitute all of these numbers in. So x is going to be equal to negative b, which is 6, plus or minus the square root of b squared, which is 6 squared, minus 4 times a, which is 1, times c, which is negative 3. All divided by 2 times a, which is 1. So now it just comes down to simplifying this. Negative 6 plus or minus, well, 6 squared is 36, and negative 4 times 1 times negative 3 is going to give me positive 12. All over, 2 times 1 gives me 2. Negative 6 plus or minus the square root of 36 plus 12 is 48. All over 2. So we need to simplify the square root of 48. So the way that we can do this is looking at what perfect square factors 48 has. 48 has a perfect square factor of 4, because 4 times 12. And then 12 has a perfect square factor of 4, because 4 times 3. So I can rewrite this square root of 48 as the square root of 4 times 4 times 3, or as the square root of 4 times the square root of 4 times the square root of 3. The square root of 4 is 2, square root of 4 is 2, square root of 3 we can't do anything with. 2 times 2 is 4 root 3. So x is equal to negative 6 plus or minus 4 times the square root of 3 all over 2. We can simplify this one step farther. 4 is divisible by 2, and negative 6 is divisible by 2. Because they're both divisible by 2, we can simplify, and we can say that, well, negative 6 divided by 2 is negative 3 plus or minus, and 4 divided by 2 is 2 times the square root of 3. So this is our final answer, negative 3 plus or minus 2 root 3. And I would double check with your teacher. Some teachers are going to be fine with this. For example, I'm perfectly happy with this as an answer. Others are going to want you to write it as negative 3 plus 2 times the square root of 3 and negative 3 minus 2 times the square root of 3. So just double check and make sure that you're giving your teacher what they're expecting. Okay, we have a second example. And again, we're just going to identify what is A, what is B, and what is C, and plug them into our quadratic formula. So x is equal to negative b, and b is negative 12, plus or minus the square root of b squared, so negative 12 squared, minus 4 times a, which is 4, times c, which is 9, all divided by 2 times a. Now we just need to work towards simplifying this. Negative negative becomes a positive, so that's 12. Plus or minus the square root of negative 12 becomes positive 144. Minus 4 times 4 is 16, times 9 is 144. Divided by 2 times 4 is 8. Well, 144 minus 144, that's very convenient. That's going to cancel out, and we're going to have the square root of 0. The square root of 0 is, in fact, equal to 0. So this whole piece right here, the square root of 144 minus 144, is going to go away. It's just 0. I have 12 plus or minus 0. Well, if I add 0 to 12, and I subtract 0 from 12, I still have just 12. And our denominator is still 8. So we can simplify this a little bit. These are both, actually let's write it like this. I can factor 12 to be 4 times 3, and I can factor 8 to be 4 times 2. Meaning these 4's can cancel, leaving me with positive 3 halves as my final answer. I don't get 2 solutions, I get 1 solution. We'll talk about the difference between 2 solutions and 1 solution and what that really means in the next few videos where we start looking at graphing quadratics. Finally, we have one more example. Identify what A is, what B is, and what C is, and then plug and chug into our quadratic formula. So negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. And then it's just working towards simplifying. So negative 3 plus or minus the square root of 3 squared is 9. 4 times 5 is 20. Times 7 is 140. All over 2 times 5 is 10. Negative 3 plus or minus 9 minus 140 is negative 131. All over 10. And when we get to this point, we should recognize that we have a square root of a negative number, which is not going to give us any real solutions. So once we see this, we can stop and say that there's no real solutions. So we looked at an example where we get no real solutions, where we get one solution, and where we get two solutions. If this video was helpful, consider dropping a like. If you still have questions about something you're confused with, or you have a topic that you would like to see me covered, go ahead and comment it below. And consider subscribing for more math lessons. Thanks, and we'll see you in the next one.